Welcome to more deep information about the basketball example made in class by Nicolás González, Sebastián Palacio, Sofía Pedraza, and me, Valeria Nieto. The first topic to review is velocity and speed, but first, we need to know that the difference between a speed and velocity is that the speed is the rate at which someone or something is able to move or operate, and velocity is just the speed of something in a given direction. Now, in the graphic shown, you can see that the speed was not constant, as it shows that in some seconds it was very fast, like in the second 10 and 60, but also it shows that the speed was slower, like in the second 18. Besides this, velocity was clearly known of going directly to the basket in order to score, as we could determine that velocity was constant and the direction didn't change at all. The next topic to review is acceleration, which is the change of speed on time. In the table shown, we can see that when the ball is pushed away, the acceleration starts to increase until it reaches the midpoint. It shows a bigger amount of acceleration until the ball is scored to the direction of going downwards, which makes an acceleration bigger in the graph. The next topic to review is vector and scalars. We need to note that a scalar is a quantity that is fully described as by a magnitude or a numerical value alone, and a vector is the quantity that is fully described by both magnitudes and directions. Aligned with the graph made, a scalar quantity is a one-dimensional measurement of a quantity like temperature or weight, and a vector has more than one number associated with. A simple example is velocity. It has a magnitude called speed, as well as a direction, like north or southwest, or 10 degrees west of north. You can have more than two numbers associated with the vector. For example, you can add a higher dimension to velocity and say, for example, I am going uphill at a 5-degree slope in the northeast direction. To understand the difference between distance and displacement, we need to understand that they are two different things. Distance will always measure in length how much the object moves, but displacement is different because it has a direction. So if something goes 5 meters forward and 2 meters backward, the displacement will be 3 meters. Distance measures how much an object travels the ending result. It will be 7 because it traveled 5 meters and the other 2 meters. In displacement will be 3 because it went 5 meters apart but became 2 closer at the end, which gave an ending distance of 3 meters. Now, with the table we show everything that was as a final result, but with two examples like the original, the one with the x-axis and the one with the y-axis.